In this video, we're going to talk about the Intermediate Value Theorem. And at the very basic part of this, really what it does is it says that a continuous function can't skip values. For example, you're in an airplane and you go from 0 to 10,000 feet up in the air. You're not going to skip the 1,000 foot mark. You're going to go through it. That's the concept behind the Intermediate Value Theorem. And this is also abbreviated as IVT. So here is our big proper definition of the Intermediate Value Theorem. It says if f of x is continuous on a closed interval from a to b, and f of a is not equal to f of b, in other words, their y values are different, then for every value m between those y values, f of a and f of b, there exists at least one value c, that's what we're going to call it, within that interval ab, such that f of c, so the y value at that c, is equal to one of those m's. So I'm going to show you what this looks like on a picture as well, so that it hopefully helps stick what this is saying. So we're going to make sure that we understand the first part of this, which is f of x is continuous on a closed interval from a to b. So when I do that, here's a basic graph, and I'm going to go ahead and start sketching a function, and I'm going to make it kind of curvy, so we've got some options here, but I'll make it something that looks a little cubic. So there's my function, and I'm going to have it go from a to b. Before we actually mark where we want a and b to be, when I come back here, their y values, this part right here, their y values have to be different. So I want to be careful as to where I put a and b. So if I put a here, so try to figure out where its y value is going to be. It looks like about there. So I'm going to have b, I'm not sure, we'll put it here. So their y values are going to be different. So that's exactly what I'm looking for that first part. And I'm going to go ahead and label this f of a, and I'm going to label, let's see, about here as f of b. So there's the first part that it's saying. In the next part it says, then for every value m between f of a and f of b. So where would m be? If you take a look at this, all of the values in between f of a and f of b here, those are my m's. So every single y value in between could be an m. And notice that if I trace my function just between a and b, this part here, okay, I should get all of the m's in there. And actually this continues to go up even farther. So this is all of m. Okay, so basically what it says is that function is going to hit every m that's in between a and b, just like that. So let's go back, and then it says, right here, that there exists at least one value c within that interval, such that f of c is equal to m. So what that means is, let's say I pick a specific m. Okay, let's say I make it 10, and I'm going to put that 10 right here. That's my 10. What it means is that if this is an eligible y value, that at some c, we're going to call it here, that f of c should be equal to that m. And that's exactly what this is. So this is my f of c, and it's equal to the m that I picked, which is 10. That's all it says. And this goes back to the very basic part that's right here. It says that a continuous function cannot skip values. If I can use this information here, then it proves mathematically that there is no room for error, that every single m is going to get used. So that's wonderful. So we now have our intermediate value theorem all panned out. We understand what it's trying to say. So now, how do I actually go about using it? So our first example is going to be to prove that the equation sine x equals 0.3 has at least one solution in the interval 0 to pi over 2. So I want you to keep in mind something, that this intermediate value theorem doesn't give us any kind of numeric value or answer. It just tells us that all y values exist. So our answer is going to be either yes or no. It's not going to be a value. So what we're going to do first is make sure, we're going to double check that sine x equals 0.3 is actually between 0 and pi over 2. And I know that the sine of 0 is equal to 0, and I know that the sine of pi over 2 is equivalent to 1. So sure enough, 0.3 fits in between that range of values. And the next thing that we have to do is make sure that our function, whatever that it is continuous. So do we know that sine x is a continuous function? And we know that it does. So we have to check off a few things to make sure that the intermediate value theorem will tell us that yes, sine x has at least one solution for it to be equal to 0.3. So here are the two things that we have to make sure that work. Is our function continuous on the interval? Yes, it is. We know that because we know the sine function to be continuous on its entire domain. Now, is f of a different than f of b? And we showed that here and here. So the answer to that question is yes. Now, since it passes those two criteria, what's our final answer? Well, what we're going to do is we're going to say therefore, so that's those three dots that are in a triangular shape, that's therefore. We're going to state what theorem that we're using, which is the IVT. The IVT tells us that sine x equals 0.3 has at least one solution in this interval. That's your answer for these kinds of problems. And if you take a look at a picture, just to make sure you understand, if I do draw my quick sketch of sine between 0 and pi over 2, it's just the top curve of that function. 0.3 is a y value, and if you do look at this picture, there's actually two solutions for this. There's one that's here, and there's one that's here. Both of those pertain to 0.3. So that's all that our function is telling us. So this actually leads us into another important point that we want to talk about, and that is the existence of zeros. So basically, if f of x is continuous on our interval, and we have two y values, f of a and f of b, that are non-zero and they have different signs, then f of x has a 0 in ab. If you take a look at a picture, this is actually very simple to see. So I'm going to start with this picture, and we're going to go like this. So I'm going to say that this is my first f of a, or y value, and that actually looks really bad. I'm going to redo that. This is f of a, and I'm going to have this guy down here be f of b, and of course this will be between a and b on the x-axis. They are non-zero. They do have opposite signs. F of a is positive, f of b is negative. Then it does tell you for sure that there is a 0 right here. And that is important to know when we start talking about bigger things in the world of calculus. This is something really important, and it's going to help you understand your functions a lot better. If you're trying to prove something or go about a problem and you automatically know that we've got a positive y value, negative y value, and it's a continuous function, you know for a fact that it's going to have a 0, at least one of them in there, and that's going to be really important in the future. So I want to make sure that I do another problem with you, just to make sure that you understand the IVT. So this next example is to show that g of t equals t over t plus 1 takes on the value 0.499 for some t within the interval 0 to 1. Now, of course, the first thing that we have to do is make sure that our function is continuous in between there and that our y values are different. So let's go ahead and do that first. So here's our setup, and if we plug in 0, we get 0 over 0 plus 1, which is going to be equal to 0 over 1, which is just 0. And for g of 1, I have 1 over 1 plus 1, which is going to be equivalent to 1/2. So sure enough, these y values are different. And we want to make sure that our function is continuous in here. If you take a look at the denominator, t plus 1, this is only discontinuous at one point, and that's going to be at t equals -1. because that makes the denominator 0. Notice that -1 is not within this interval, so we don't have to worry about that, which means that between 0 and 1, this function is continuous. So here we have our checklist, and I added in one last thing that we didn't really go over as a bullet point last time, which is that our value, in this case 0.499, is within our interval. And I'm sorry, that's actually incorrect. This is a y value, so that needs to be between f of a and f of b. And please be aware that this 0.499, that's the m that we were talking about. And we're trying to find that there's some c that gives me that m after I plug it in. So is this function continuous? Yes, it is. We double checked that. Are the y values for the interval different? Yes, they are. And is 0.499 between 0 and 1/2? Just barely, but it is. So, does a c exist that gives me that m? And the answer is yes, because it passes the IVT. And so this is an example of what our answer could look like. The IVT proves that there exists at least one c in our interval AB, such that f of c is equal to 0.499. And of course, if you'd like to, you can change your interval AB to be the actual interval that we have, which is 0 to 1. So there's a couple different ways that you can go about answering that question. So that's our IVT, and that will conclude this tutorial.